All right, let's dive right in. Today, we're talking about something that's, well, it's absolutely critical, but somehow gets overlooked all the time. We're talking about managing software boundaries. You know, that line in the sand between the code you write and all the code you don't. The third-party libraries and APIs our systems totally depend on.
And that's a question you've really got to ask yourself. Because when we pull in external code, we're basically trusting someone else's work, right? And if you don't have clear boundaries, a tiny change on their end can open up a massive sinkhole in your project. So how do we make sure we're building on solid ground?
Look, using external code always means giving up some control. It's just the reality of it. But creating clean boundaries is all about grabbing that control back. It's about protecting our work and making sure our code can actually adapt and change over time. So let's walk through 3 really powerful ways to do exactly that.
Okay, first things first, we have to get our heads around the real problem here. There's this natural tension every single time we use a third-party library. It's a conflict between what the people who made the library want and what we, as the users, actually need.
In this slide, it just nails the issue perfectly. The library folks, they're trying to build something for everybody. So they make these big, powerful, do-everything tools. But in our app, we don't want a Swiss Army knife. We need a scalpel. We need an interface that's hyper-focused on our specific problem. And that mismatch, that's where things get dangerous.
Let's make this real. The source material uses the absolute perfect example: Java's good old map interface. It's everywhere, it's incredibly useful, and that very power is exactly what can make it such a liability if we're not careful. I mean, just look at this. The map interface hands us this huge arsenal of methods. But what if, in our application, we have a map of user settings that should never be cleared? Well, that clear method is sitting right there, just waiting for someone somewhere in the codebase to call it. We're getting way more power than we need, and all that extra power is just risk. So here's the bottom line. When we just pass a raw map all over our system, we're not just passing our data. We're dragging its entire, overly powerful interface with it. We're forcing every piece of our code to know its dirty little secrets, like having to cast objects, and we're basically leaving the door wide open for someone to misuse it. So how do we fix this? Well, the first strategy is all about containment. Instead of letting that big, clunky interface run wild through our system, we're going to build a wall around it. We build our own little fortress with our own tiny, well-guarded gate.
This is the before picture, right? This is what it looks like when the boundary is just a total mess. Our code is completely tied to the map. It knows it's a map. It knows it has to do this ugly cast, and it can do anything and everything a map can do.
But the solution, it's just so much cleaner. We create a new sensors class. Now, deep inside, it's using a map, but nobody on the outside knows that, and more importantly, nobody cares. All they get to see is this one beautiful, simple method, getById. The messy boundary is now completely hidden from view. And the payoff here is just huge. Our interface is now perfectly tailored for our app. It's way harder to misuse. There's no clear dot method to call by accident. And you know what? If, down the road, we decide a map is too slow and we want to use something else, no problem. Only that one sensors class has to change. The rest of our system is completely protected.
Okay, our second strategy tackles a totally different but just as common problem. How do we start using a new library without spending days debugging our own code? The trick is to use tests, but not just for checking our work. We're going to use them to explore.
Oh man, we have all been there. You read the documentation, you write the code to integrate the new library, and then you spend the next 5 hours in the debugger just trying to figure out if the bug is in your code or if the library just doesn't work the way you thought it did. There is a much, much better way. And that way is what we call learning tests. Seriously, think of them like little science experiments for your code. Before you even think about putting that new library into your real application, you just write a few simple tests to prove to yourself that it actually does what you think it does. You're learning the API in a safe, totally isolated sandbox. I love how the source material puts this. It says learning tests are better than free. They're not a cost, they're an investment. And the return is fantastic. You have to learn the API anyway, right? Doing it this way is just faster, more precise, and it creates documentation as you go. And that return on investment is massive. A few months later, when that library pushes out a new version, you don't have to cross your fingers and hope it doesn't break everything. You just run your learning tests. If they pass, you're golden.
If they fail, you know exactly what changed and how it affects you. These tests become your living, breathing contract with that outside code.
Now, our final strategy is maybe the most powerful of all. It's a bit of a pro move, and it answers a question that pops up on big projects all the time. What do you do when the code you need hasn't even been written yet?
Picture this. You're waiting for another team to build some API for, let's say, a transmitter system. You know what you need from it, but they're still in meetings trying to design it. So what do? Just stop working? Absolutely not. You define the boundary yourself.
The big idea here is a total game changer. You don't wait for them. You design the interface that you wish they would give you. So in this diagram, we've created our own transmitter interface. It's clean, it has exactly what our communication controller needs, and, this is the important part, it's 100% under our control.
So what's the magic that connects our perfect interface to whatever the other team eventually builds? It's a classic design pattern called the adapter. This transmitter adapter becomes the one and only place in our whole system that knows about the messy details of the real API. It's like a universal translator, bridging the gap between the world we want and the world we get.
And this just demonstrates the power of taking back control. Your code instantly becomes more readable because it's talking to an interface that was built for it. You're completely insulated from their future changes. And best of all, you've created this perfect seam for testing. Now you can just pop in a fake transmitter and test your controller without ever needing their real system.
So when you pull back and look at all three of these strategies, wrapping your APIs, writing learning tests, and using adapters, what do they all have in common? It's simple. They are all about consciously, deliberately managing your software boundaries so you can stay in control. And this right here, this is the whole thing. It's the most important takeaway. When you let the specifics of some third-party library leak all over your code, that library ends up controlling you. It controls your design, your architecture, your ability to change. Clean boundaries put you back in the driver's seat. So I'm going to leave you with this question to chew on for your own projects. Where are your boundaries weakest? Where are you passing a raw map around? Where are you calling some external API from a dozen different places? Find those spots, because those are your weakest points, but they're also your best opportunities to start building a cleaner, stronger, more resilient system. Thanks for tuning in.